From this session onwards, I want to make certain fundamental change in the way the topic is going to be discussed. I got certain requests which have asked me to deal the subject also in the form of the question and answers, and those questions that can be asked in the preliminary examination, which are of course the concept based questions. Now from this particular topic onwards, that is the tilt and solar altitude as a basic concept of this planet Earth onwards, I'll try to have these questions posed. First, try to find the answer if you have already completed the syllabus, and if you haven't, try to learn the concept behind these questions such that you can find the right answer. Now look at this particular question related to this tilt and solar altitude as a basic concept of planet Earth. It gives you the two fundamental statements, and whether these statements are true or false have to be found out. The first statement says that the maximum solar altitude varies at any location on the surface of the Earth to the extent of 69.5 degrees, and the second statement says that whether during the two equinoxes this subsolar point occurs on the equator or not. These two are fundamental concepts related to the tilt and solar altitude. Now if you want to try this question, please pause the video and try to find the right answer. Now if you have found the right answer, really you are good at the concepts. Now let me deal with the concepts behind these two statements. Remember that the planet Earth has its axis tilted to the ecliptic plane, that as we have learnt in the last session, and as per this particular tilt that we find, we know that the rotation of the Earth and the revolution of the Earth give rise to certain fundamental phenomena. We have also learned that the axis of the Earth is clearly in a constant position if you look at it from the perspective of rotation. However, its position relative to the Sun is continuously changing on the ecliptic path that it is taking, if I take into consideration the revolution. And depending upon this, we find that even if you observe the sky in general on a random day throughout the year, you find that the position of the Sun as part of the apparent movement of the Sun as an observer on the surface of the Earth will find lot of variation. This is what has been measured in terms of altitude of the Sun. If I take into consideration both the solstices and the equinox, if you observe this particular picture, you find that this is the true south and this is the true north, and we find that the Earth is finding the apparent movement of the Sun having an observer on the surface of the Earth. On the basis of this, if you look at this particular picture, you find that the altitude of the Sun as part of the summer solstice or the June solstice is finding a particular path, and on the day of equinox it is finding another particular path, and on the day of winter solstice it is again finding a particular path. On this entire path, if you observe, you find that the this solar altitude is not constant, but it is in variation. This is varying from this particular point to this particular point, and on the again based on the revolution of the Earth, its position will be relatively changing in terms of altitude. Now look at the concepts behind these. So as I told you, the annual change in the relative position of the Earth's axis in relationship to the Sun has to cause the height of the Sun, or so-called solar altitude, to vary. And this is the reason why you find that the solar altitude is varying in our skies. So the solar altitude has to be defined. What is the solar altitude? The solar altitude is normally measured either from the southern or northern point along what? Along horizon. And hence it has to begin at what? 0 degrees. So if I am trying to measure, suppose from true north position or from true south position, if I have to consider that I am measuring from the true north position, and if this is being taken as 0 degrees, because that is the point at which it has to start, as it is trying to measure the entire the variation in the altitude possible, it takes into consideration almost 180 degrees now. So from 0 degrees to 180 degrees is the possibility that we find, because from north to south it is half of the entire circular circumference that is possible, and hence 180 degrees is the measurement that we must consider here. Number one. Number two, if you look at the maximum solar altitude that is possible to occur on the surface of the earth, you also know that it occurs on the day of equinox, when the solar insolation is exactly overhead to the equator. That means at this particular point, or any point that you are considering on equator, sun is clearly 90 degrees overhead at what? Noon. That means maximum solar altitude that is possible to occur is 90 degrees, and this occurs on what? This occurs on the day of equinoxes, particularly on equator. Number one. Number two, the maximum solar altitude now for any location on the surface of the earth over a period of 1 year, if I take into consideration, because for the ecliptic path to be completed, it takes into account 1 year of time to complete that one entire revolution. If I consider the total variation that is possible in terms of maximum solar altitude for any location on the surface of the earth over this entire 1 year period, that has to be what? 47 degrees. Now, why? Here you know that on the day of equinox, the solar altitude is exactly 90 degrees. However, if I take into consideration both 23.5 degrees north and 23.5 degrees south as the important parallels, you also know that on the day of solstices, the solar insolation is exactly at 90 degrees over the 23.5 north. 23.5 north, and on the day of winter solstice, that is on the day of December solstice, the solar insolation is exactly 90 degrees, that is overhead to the 23.5 degrees south. Why? When we find that on the day of on the day of summer solstice or the June solstice, the sun is overhead at this particular point called 23.5 degrees north as a parallel that is drawn to the equator. We must remember that the north pole is tilted 23.5 degrees towards the sun, and hence we also have to understand here that this particular tilt of 23.5 degrees towards the sun causes the entire solar insolation to occur perpendicular to the 23.5 north as a parallel that is drawn to the equator. And similarly, on the day of December solstice, you find that the 23.5 degrees inclination of south pole towards the sun is possible, and hence sun is exactly perpendicular on this particular day to the 23.5 south as a parallel drawn to the equator. And hence, if I take into consideration, this is the possibility. So the maximum solar altitude in terms of its variation has to occur what? From 23.5 north to 23.5 south as an angle that has to be considered, and hence it has to be 23.5 into 2 equal to 47 degrees. That means whatever the earth's tilt that you have in terms of 23.5 degrees, it is this 23.5 degrees north and 23.5 degrees south which forms the boundary for the solar insolation to occur perpendicular onto the surface of the earth. So based on this concept, we have to understand that the variation in the solar altitude occurs between these two 23.5 and 23.5, and hence it has to take into consideration a maximum solar altitude possible in terms of its apparent movement for the sun is 23.5 into 2, that is 47 degrees. That means whatever the first statement that has been given in the question, where the maximum solar altitude varies at any location on the surface of the earth to the extent of 69.5 degrees is wrong. The correct answer is 47 degrees. Now the second statement must also be considered here. For understanding this, we must now look at what is this concept called subsolar point. Remember that there is a location on the surface of the earth, and on this particular location, on the day of any particular solar day, you find that at noon it is overhead. Whenever sun is overhead at a particular solar noon, that particular point is called as subsolar point. I repeat, the location on the surface of the earth where the sun is directly overhead at any solar noon is known as subsolar point. Now if I take into consideration what is called as these two equinoxes, you find that the subsolar point occurs on the equator during the two equinoxes. Why? We find that on these 2 days of two equinoxes, the equator is clearly lined up with what? The ecliptic plane, and the poles are also in line with what? The circle of illumination, which divides day and night into two equal halves. And because of this, we find that equator is clearly finding sun overhead at this particular solar noon on these 2 days of two equinoxes, and hence any point on the equator, any location on the equator must be considered as subsolar point. Any location on equator must be considered as subsolar point on the day of two equinoxes. So during the summer solstice, we find that the subsolar point is moving towards the Tropic of Cancer, because at this time, as I told you, the North Pole is inclined 23.5 degrees towards the sun, and hence on the day of summer solstice, any location on the Tropic of Cancer must be considered as subsolar point. And if you look at this particular graph, it clearly gives you the way the subsolar point is varying. In this particular picture, the subsolar point gradually changes from one day to the next over a period of entire 1 year. Note that this particular graph is taking into consideration the tilt of the earth and the declination of the sun. And here, declination of the sun has been measured between 23.5 degrees to again 23.5 degrees, and the entire calculation will again lead to what? The 47 degrees declination which is possible for the sun. And in this particular picture, the subsolar point at the start of the study is at this particular point, that is at the Tropic of Capricorn, which we call as 23.5 south parallel. And on this particular day, we know that the sun is overhead now here, and that means this is December solstice. That means on this day of December solstice, at this any particular location on the Tropic of Tropic of Capricorn is finding sun overhead, and from this point now the solar declination starts occurring. And you observe that during the December solstice, during which South Pole is angled 23.5 degrees towards the sun, is now started changing and its course, and simultaneously you observe that on the day of June solstice, it reaches the Tropic of Cancer, during which for these all 6 months the sun's declination occurs, and the sun's declination is clearly 23.5 degrees. That means for the 6 months of period, the declination is 23.5, and on this particular day you observe that the sun is exactly overhead at any location on the surface of the earth which is falling on this particular parallel called 23.5 north. And on the day of March equinox, you observe that sun is overhead on the equator, and again on the day of September equinox, sun is overhead on the equator. Again, if you come back to the December solstice, it is again overhead at any location on the Tropic of Cancer or 23.5 south parallel that is there on the southern hemisphere. And this is how the entire declination of the sun occurs. Now look at the second statement. The second statement says that during the two equinoxes, the subsolar point occurs on the equator, and this is the right statement that has been given, and hence the answer has to be B for this particular question. And if you can observe this particular topic, you find that I have given some of the maximum solar altitudes that is possible for any particular latitude by taking into consideration some of the important latitudes. And if you observe here, for 90 degrees north, the March equinox will have a declination of 0, or the maximum solar altitude possible is 0, because on the day of equinox, as I told you, the sun's radiation starts occurring exactly after this particular day, as we know that the circle of illumination that we have understood in the last session and also in this particular session is exactly going through both the poles, because the solar radiation is occurring exactly perpendicular to the equator, and hence at 90 degrees north on the day of March equinox, the solar altitude has to be 0. That means it is not just even above the horizon. Similarly, for 90 degrees south also it is at 0 degrees. And again, if you consider the September equinox, you find that it is at 0 degrees. However, for 90 degrees north, if you look at the June solstice, as I told you, the solar insolation is occurring here, and as we know that 23.5 degrees is the tilt of the north pole towards the sun, and hence if you observe the horizon from the north pole, you find that sun is hovering over the north pole in a circular manner at an altitude of 23.5 degrees, and hence on the day of June solstice it is exactly at 23.5 degrees, and again it is completely in daylight, and this continues for almost 6 months from the day of March equinox to September equinox, and hence on the day of June solstice we find that it is at this particular circumference that it draws because of the apparent movement of the sun that we see as an observer from the north pole, and the entire south pole is in darkness, and whatever the calculation that we get is minus 23.5 degrees. And if you observe the December solstice, it gets reversed. So like this I have given the values for various latitudes. Please note down these values and try to understand the concept behind these solar altitudes, which are maximum values possible at that particular latitude. And if you have to understand this in terms of a formula, that formula can also be written like this. Suppose I am calculating the altitude of the sun at solar noon. You can use this equation 90 minus latitude L plus or minus declination D. As it is written here, if the sun angle determination is for a solstice days, you know that the declination has to be added to the latitude if the location is experiencing summer. If you know that it is summer, and if you know that it is June solstice, the northern latitudes are experiencing summer and the southern latitudes would experience summer during the December solstice. And if it has to be considered for the winter, or if the location is experiencing winter, as you understand, northern latitudes experience winter during this December solstice and southern latitudes experience winter during the June solstice, it has to be subtracted from the latitude. So all the answers from this equation are given relative to the true north for southern latitudes and true south for northern latitudes, because the possibility of observation will be from only these two points on the surface of the earth. And for our purposes, if you look at the declination of the two solstices and two equinoxes, they are important for the exam, and the values that you have to remember for these four very important dates are: on the day of June solstice, you know that declination is 23.5. On the day of December solstice, the declination is minus 23.5. And March equinox and September equinox will have a declination of 0 if I am taking into consideration northern hemisphere, and the values would reverse if it is for the southern hemisphere. And this is what the concept of tilt and solar altitude is all about. In the next concept, we will try to know the intensity of the solar insolation and how it gets varied over the surface of the earth over a period of